Hi, this is Adam of American Teacher on YouTube. If you haven't, please click the subscribe button under the video and give me a thumbs up, and thank you for watching. Today's topic is about climate change, and I know this is not a new topic, and it's probably not a very popular topic, but this is something we're going to have to deal with in the near future. Well, we're starting to deal with it now. And I think the reason why many people don't really want to face this fact is partly because of nostalgia. Ever since I can remember, American culture has revolved around the car. Traveling, having your own car. Where I lived in Tennessee, if you didn't have a car, you didn't have legs. You didn't go anywhere because I lived in a small town in rural Tennessee, and there were no buses, no taxis, no public transportation to speak of. And so your car was your legs. And in America, we kind of have a relationship with our car. I mean, it's not like it's hard to describe, but people name their cars many times in the U.S. And they're oftentimes proud of their cars. They'll keep them clean. They'll get them maintained, spend their weekends maybe waxing their car, taking really good care of it. And so we are really attached to our cars. And I was just thinking about it. There is a certain nostalgia with internal combustion engine cars. The roar of the engine, the smell of the gasoline, just the experience of driving one. And so I think a lot of people, they don't want to give up their past. And gas-powered cars are like a fixture of American culture. I can remember as a child I subscribed to Car and Driver magazine. I used to could tell you every make and model of car on the road. I had my dream cars picked out in the future. Now that I'm older, of course, I don't really particularly care that much as long as my vehicle runs and is safe to drive. But when I was younger, I used to have dreams about having sports cars and things like that. But what am I getting to? Well, oil and the use of fossil fuels has become political in the U.S. You can't discuss the end of oil without people automatically branding you as a liberal, progressive Democrat, and also they think you want to get rid of jobs for people who work in the oil industry. And that's, of course, not what anyone wants. I mean, we don't want to get rid of jobs. I don't think any American could say, oh yeah, I want to get rid of these people's jobs. The thing about it is, we are experiencing climate change. And it's not just in the U.S., it's here in Taiwan also. Last May was the hottest May on record in Taiwan. This past May, 2021. And there are other pieces of evidence around the world that climate change is a real thing and is something we need to address. So I've got a NASA website pulled up, NASA Global Climate Change, and it asks, how do we know? How do we know that things are changing? Well, they've got a chart that shows the level of carbon dioxide in the atmosphere over the past hundreds of thousands of years. And as you can see towards the end here, this is in modern times, modern days, the industrial and the post-industrial era. You can see for millennia, for thousands of years, atmospheric carbon had never been above this line where the arrow is pointing. But around 1950, after World War II, you can see that the carbon dioxide level jumped up, and it's continued to skyrocket to its current level, which is much higher than it's been in the past thousands of years. So so it says Earth's climate has changed throughout history. Just in the last 650,000 years, there have been 7 cycles of glacial advance and retreat, with the abrupt end of the last ice age about 11,700 years ago, marking the end of the modern climate era. Marking the beginning of the modern climate era and of human civilization. So most of the prehistorical climate changes were attributed to very small changes or variations in Earth's orbit that changed the amount of solar energy that the Earth receives. They point out, according to the Intergovernmental Panel on Climate Change, scientific evidence for warming of the climate system is unequivocal. So some people might say, well, there are cycles of ice ages and cycles of warmer periods, and this has been going on since before humans. And that is true. There are cycles of ice ages and warm periods that are caused by the variance in the Earth's orbit. But what NASA is trying to point out is that since the Industrial Revolution, this change has sped up to a much faster rate than we would expect were humans not to be polluting the Earth. They point out that Earth orbiting satellites and other tech advances have enabled scientists to see the big picture. And so here's some of the evidence. The planet's average surface temperature has risen about 2.12 degrees Fahrenheit or 1.18 degrees Celsius since the late 19th century. And they point out this change is largely driven by the rapid increase in carbon dioxide emissions into the atmosphere and other human activities. Most of the warming occurred in the past 40 years, with the 7 most recent years being the warmest. The years 2016 and 2020 are tied for the warmest year on record. Warming ocean. The ocean has absorbed much of this increased heat, and we'll talk about how the ocean can affect weather patterns in just a minute. So it says the top 100 meters or 328 feet of ocean show more than 0.6 degree Fahrenheit temperature increase since 1969. 0.6 degrees Fahrenheit is about 0.33 degrees Celsius. So the temperature of the ocean is rising as well. Also, they point out other evidence: shrinking ice sheets. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show that Greenland lost an average of 279 billion tons of ice per year between 1993 and 2019, while Antarctica lost about 148 billion tons of ice per year. Glacial retreat. Glaciers are retreating almost everywhere around the world, including in the Alps, Himalayas, Andes, Rockies, Alaska, and Africa. Decreased snow cover, which also affects global temperature because snow reflects some of the heat from the ground. So satellite observations revealed that the amount of spring snow cover in the northern hemisphere has decreased over the past 5 decades, and the snow is melting earlier. Sea level rise. The global sea level rose about 8 inches, or 20 centimeters, in the last century. The rate in the last 2 decades, however, is nearly double that of the last century, and accelerating slightly every year. So the main thing to note is not that it's taken it 100 years for the sea level to rise 8 inches. It's that most of this rise has taken place in the last 20 years. Okay, declining Arctic sea ice. Both the extent and thickness of Arctic sea ice has declined rapidly over the last several decades. And extreme events. The number of record high temperature events in the U.S. has been increasing, while the number of record low temperature events has been decreasing since 1950. The U.S. has also witnessed increasing numbers of intense rainfall events. Ocean acidification. Since the beginning of the Industrial Revolution, the acidity of surface ocean waters has increased by about 30%. This increase is the result of humans emitting more carbon dioxide into the atmosphere, and hence more being absorbed into the ocean. The ocean has absorbed between 20 and 30% of total anthropogenic carbon dioxide emissions in recent decades. 7.2 to 10.8 billion metric tons per year. Okay, so this is all at climate.nasa.gov. You can check the footnotes. They have references at the end of the article. Okay, also at NASA they are listing why this is a problem, the effects, what this means. And they say that the potential future effects of global climate change include more frequent wildfires, longer periods of drought in some areas, and an increase in the number, duration, and intensity of tropical storms. And I know recently the U.S., for the first time in history, I think it was a year or two ago, they ran through the alphabet for naming tropical storms or hurricanes, and they had to go into the Greek alphabet, and they ran through the Greek alphabet. So this is unprecedented, the number of tropical storms that have been affecting the U.S. Not only the U.S., around the world. So NASA says that global climate change has already had observable effects on the environment. Glaciers have shrunk, ice on rivers and lakes is breaking up earlier, plant and animal ranges have shifted, and trees are flowering sooner. Effects that scientists have predicted in the past would result from global climate change are now happening or occurring. The loss of sea ice, accelerated sea level rise, and longer, more intense heat waves. So the Intergovernmental Panel on Climate Change says, taken as a whole, the range of published evidence indicates that the net damage costs to the net damage costs of climate change are likely to be significant and to increase over time. And I want to stop on that point because a lot of people talk about the cost of changing to cleaner forms of energy. And many people believe that the cost savings of switching to greener energy will be recouped by the the lowering in the global temperature, and the less frequent adverse climate events. Okay, it says scientists have high confidence that global temperatures will continue to rise for decades to come, largely due to greenhouse gases such as CO2 and methane produced by human activities. The Intergovernmental Panel on Climate Change, which includes more than 1,300 scientists from the U.S. and other countries, forecasts a temperature rise of 2.5 to 10 degrees Fahrenheit over the next century. According to the IPCC, the extent of climate change effects on individual regions will vary over time, and with the ability of different societal and environmental systems to mitigate or adapt to change. And I want to interject that this is why adopting greener energy is something that needs to be a global effort, and that really we need to invest not only in our own country but in other countries to adopt cleaner energy, because we all have to share the planet and we will all deal with climate change. Okay, so the IPCC predicts that increases in global mean temperature of less than 1.8 to 5.4 degrees Fahrenheit above 1990 levels will produce beneficial impacts in some areas and harmful ones in others. The net annual cost will increase over time as global temperatures increase. Taken as a whole, the range of published evidence, according to the IPCC, indicates that the net damage costs of climate change are likely to be significant and increase over time. And they have a list of future effects. Global climate change is projected to continue to change over this century and beyond. The magnitude of climate change beyond the next few decades depends primarily on the amount of heat trapping or greenhouse gases emitted globally and how sensitive the Earth's climate is to those emissions. Because human-induced warming is superimposed on a naturally varying climate, the temperature rise has not been and will not be uniform or smooth across the country over time. So they're pointing out that this will impact different areas in different ways. Frost-free season and growing season will lengthen. The length of the frost-free season and the corresponding growing season has been increasing nationally in the U.S. since the 1980s, with the largest increase occurring in the western United States, affecting ecosystems and agriculture. Across the U.S., the growing season is projected to continue to lengthen. It says in the future, if we don't curb the greenhouse gases, increases of a month or more in the length of the frost-free and growing seasons are projected across most of the U.S. by the end of the century. Okay, changes in rain and precipitation patterns. Average U.S. precipitation has increased since 1900, but some areas have had greater increases than the national average, and some areas have had decreases. More winter and spring precipitation is projected for the northern U.S. and less for the southwest over this century. Projections of future climate over the U.S. suggest that the recent trend towards increased heavy precipitation events will continue. This trend is projected to occur in regions where total precipitation is expected to decrease, such as the Southwest. So more unpredictable weather and overall more precipitation in the continental U.S. More droughts and heat waves. Droughts in the Southwest and heat waves, periods of abnormally hot weather lasting days to weeks everywhere, are projected to become more intense. I know recently areas like in the Northwest have been having a heat wave in the U.S. And they say that cold waves will become less intense everywhere. So summer temperatures are projected to continue rising, and a reduction in soil moisture, which exacerbates heat waves, is projected for much of the western and central U.S. in the summertime. By the end of the century, what have been once in 20-year extreme heat days are projected to occur every 2 to 3 years over most of the country. So, yeah, hotter weather, drier in some parts, wetter in others, more extreme weather. Hurricanes will become stronger and more intense. The intensity, frequency, and duration of North Atlantic hurricanes, as well as the frequency of the strongest Category 5 and Category 4 hurricanes, have all increased since the early 1980s. The relative contributions of human and natural causes to these increases are still uncertain. Hurricane-associated storm intensity and rainfall rates are projected to increase as the climate continues to warm. Okay, and sea level will rise by 1 to 8 feet by 2100. Now, some of you, like myself, probably won't be here. Well, I won't be here in 2100, but your children will. Your grandchildren will. So global sea level has risen about 8 inches since reliable record keeping began in 1880. It's projected to rise another 1 to 8 feet by 2100. This is the result of added water from melting ice and the expansion of seawater as it warms. And I want to talk about salinity after I finish this article, how salinity changes when the sea level rises and how that affects weather patterns. Okay, it says in the next several decades, storm surges and high tides could combine with sea level rise and land subsidence to further increase flooding in many areas or regions. Sea level rise will continue past 2100 because the oceans take a very long time to respond to warmer conditions at the Earth's surface. So there will be a little bit of a delay from the air temperature increase to the sea temperature increase. Ocean waters will therefore continue to warm, and sea level will continue to rise for many centuries at rates equal to or higher than those of the current century. And the Arctic is likely to become ice-free. The Arctic Ocean is expected to become essentially ice-free in the summer before mid-century. And they list some regional effects in the U.S. In the Northeast, heat waves, heavy downpours, and sea level rise pose growing challenges to many aspects of life. And they point out that ecosystems will be increasingly compromised. In the Northwest, changes in the timing of stream flow reduce water supplies for competing demands. Sea level rise, erosion, inundation, and risks to infrastructure and increasing ocean acidity pose major threats. Also, increasing wildfire, insect outbreaks, and tree diseases could cause widespread tree die-off. Okay, in the Southeast, sea level rise poses widespread and continuing threats to the region's economy and environment. Extreme heat will affect health, energy, agriculture, and more. Decreased water availability will have economic and environmental impacts. In the Midwest, extreme heat, heavy downpours, and flooding will affect infrastructure, health, agriculture, forestry, transportation, air and water quality, and more. They also point out a risk to the Great Lakes. Southwest, increased heat, drought, and insect outbreaks, all linked to climate change, have increased wildfires, declining water supplies, reduced agricultural yields, health impacts in cities due to heat, and flooding and erosion in coastal areas are additional concerns. Okay, so you can find all this along with references at climate.nasa.gov/effects. Okay, so I was going to talk about how the saltiness of the ocean affects climate and the water cycle. Back in 2011, NASA published an article talking about salinity in the oceans and their satellite mission to study it in more detail. So salt concentrations in the Earth's ocean exist in a narrow band, usually between 32 to 37 parts per thousand. Within this range, even smaller fluctuations can significantly change global weather patterns. They say the salinity difference between an El Nino year and its sibling climatic version, La Nina, is a single part per thousand. Okay, so one single part per thousand can make the difference between an El Nino year and an El Nina year. Just that tiny change in saltiness of the ocean. Quote, small salinity changes have a large effect on water density. Oceanographer Gary Lagerlof from Seattle-based Earth and Space Institute research told Circle of Blue. These changes can set up density gradients that cause seawater to move and climate patterns to shift. The density of seawater is a function of salinity and temperature. Saltier water is heavier and will sink deeper into the ocean, where it joins currents that circulate water around the globe. These currents, like the Gulf Stream, from the Florida coast to northern Europe, affect how the ocean transports heat, which in turn influences rainfall patterns. Precipitation completes the cycle by altering salinity, both through rainfall over the ocean and continental water flows. So stable salt densities in the ocean keep the Earth's climate in balance, scientists believe. If the density of salt in the ocean were to oscillate or change irregularly, and some studies have shown a slower circulation pattern in the last half century, the congenial climate known to most of humanity would be thrown out of whack. So we due to the changing salinity of the ocean, it caused more extreme weather events. I'm not going to read through the whole article. It's at circleofblue.org/2011/world /NASA-measures-how-ocean salinity affects climate and water cycle. Anyway, it's at circleofblue.org, and you can find that article about the NASA's mission to measure ocean salinity. So I've established why we need to worry about climate change. But there's other reasons. Oil is a finite resource. According to Worldometer, worldometers.info/oil, the amount we have about 47 years of oil left at current consumption levels. That's not accounting for any increase in consumption as the population increases. And again, in 47 years, I'll probably be gone. But like I said, there will still be humans here on Earth. You don't want to leave them a place that has limited or no energy resources. And we have the technology now to wean ourselves off of oil and off of energy sources that pollute the environment and increase global warming and affect our weather patterns. One of those is, and I know you've heard a lot about this, electric cars. And some people have put out conflicting information saying that electric cars are actually dirtier than gasoline-powered cars. And this is just not true. So according to this Reuters article, it says that in the United States, your electric car will do less harm to the environment than a gas-powered car after you've driven 13,500 miles. And that is using an algorithm created by a model created by the Argonne National Laboratory in Chicago that takes into account the different types of metals and production methods for electric cars. It takes all those things into consideration. So in the US, you would only have to drive your electric car 13,500 miles before it would do less harm to the environment than a gas-powered car. And that's not taking into consideration that battery technology is set to become more efficient in the near future. I've read several articles about new battery technologies that are very promising, that can store greater densities of energy in smaller space using materials that are not as harmful to the environment. So, but anyway, today you could buy an electric car, and in 13,000 miles you'll be doing less harm to the environment than a gasoline-powered car. Given that most cars are supposed to run for about 100,000 miles at least, that is a huge savings to the environment over the lifespan of an electric car. Also, people point out that well, we get our electricity from a grid, and some of the forms of energy are not environmentally friendly, like burning coal. Well, the U.S. is lucky. In the U.S., coal is a minority percentage of energy production, coal and oil, and so by using an electric car, you can actually help the environment. In some countries, they still burn mostly coal, and electric cars would have less of an impact on the environment in those countries. But it doesn't change the fact that electric engines are vastly more efficient than, and convert more power to the wheels of the car than gas-powered engines. So electric engines are much more efficient. They don't have the same roar, they don't have the same feel of a gas-powered car. But I think I can give up a little bit of nostalgia for the sake of the planet. Not only that, there are other sources of energy that are being looked into besides even solar panels, which I looked at another article that claimed that you can recoup, depending on where you live, that some places have subsidies for solar panels for the home. You can, in some places, you can recoup your costs for installing a whole house solar system in as little as 6 years, all the way up to 15 years, depending on where you live, the size of your house, and other factors. So you could actually, over the life of solar panels, end up saving money in the long term by going solar. It does have, solar energy for homes does have a very high upfront cost, but over time, in most areas, solar will pay for itself. Okay, so the main point, what's the point? We can all do things to reduce greenhouse gas emissions, and we all need to do things to reduce greenhouse gas emissions. Don't be too nostalgic about the past. You can have your memories of your gas-powered car, take pictures of it, take videos. You're not going to die if you have to drive an electric car, and you could save humanity in the process. Thank you for watching. I'm sorry I rambled on for so long. This is American Teacher, and if you haven't, click subscribe, give me a thumbs up. Thank you for watching.